Before you walk into a backend interview, it's crucial to understand what interviewers are really looking for. They're not trying to trip you up with obscure puzzles. Instead, they're checking if you've encountered the real-world problems that backend systems face in production. After failing several interviews and eventually becoming an interviewer myself, I realized the same 20 core concepts come up time and again. If you can confidently discuss these, you'll have the foundation to pass a mid-level backend interview loop. Let's dive into why these questions matter and how understanding them, not just memorizing answers, can set you apart. Databases, where most applications spend the majority of their time. A common question is, what happens when you put an index on a random UUID column? Many developers use UUIDs for primary keys because they're easy to generate in distributed systems. However, random UUIDs can cause significant page fragmentation in B-tree indexes, leading to constant disk writes and performance issues. Understanding why sequential IDs or time-sorted UUIDs are better for indexing is essential for efficient database operations. Another frequent database question is about pagination. How do you paginate through 50 million rows without using offset? Offset and limit work for small datasets, but as you go deeper into the pages, the database has to scan and discard more rows, making queries slower. Keyset pagination, also known as cursor-based pagination, keeps query times consistent regardless of page depth. Knowing how and when to use this approach is a key skill for any backend engineer. And should you use a composite index instead of two separate indexes? If you often query a table using two columns together, creating separate indexes on each column isn't optimal. Most databases use only one index per table scan. A composite index on both columns, A, B, allows the database to efficiently filter results, and the order of columns in the index matters. Understanding how composite indexes work can significantly improve query performance. N+1 query problem is a classic performance bug, especially with ORMs. For example, you query a list of users, and for each user, the ORM fires a separate query to fetch their profile. This leads to a huge number of queries and slow performance. The solution is to use explicit joins or eager loading to fetch all necessary data in fewer queries. Recognizing and fixing N+1 problems is a must-have skill for backend developers. Concurrency issues are common in distributed systems. For instance, how do you prevent double booking a ticket? Simply checking availability and then booking can create race conditions. Application-level mutexes don't work across multiple servers. Instead, you need database-level locks like select for update or optimistic locking with version numbers. These strategies ensure that only one booking can succeed, even when multiple requests happen simultaneously. Understanding database isolation levels is crucial. What's the difference between repeatable read and serializable? The default isolation level in many databases, like Postgres, allows certain race conditions. Serializable isolation is stricter and guarantees absolute correctness, but can impact performance. Knowing when to increase the isolation level is key to preventing subtle bugs in concurrent transactions. When multiple workers need exclusive access to a resource, you need a distributed lock. Using a single Redis instance works until it goes down, creating a single point of failure. Algorithms like Redlock or systems like Zookeeper provide distributed consensus, ensuring that locks are reliable even if some nodes fail. Understanding these mechanisms is vital for building resilient distributed systems. Idempotency is essential for payment endpoints. If a client retries a payment request due to a dropped connection, you must ensure they aren't charged twice. This is done using idempotency keys, which are stored and checked to guarantee that each payment is processed exactly once. Knowing where and how to store these keys is a critical backend skill. Caching can speed up your system, but it introduces new challenges. A cache stampede happens when a popular cache key expires and thousands of requests hit the database at once. This can overwhelm your backend. Solutions include probabilistic early expiration or using a lock to ensure only one thread regenerates the cache. Understanding these strategies helps you design robust caching layers. Invalidating cache correctly is a hard problem. For example, if you cache a user profile, how do you invalidate it when they update their email? You need to understand the difference between write-through and cache-aside patterns, and the trade-offs between setting a short time-to-live versus explicitly deleting the cache key on updates. Mastering these strategies is crucial for maintaining data consistency. Sometimes, adding Redis or another cache in front of your database can actually slow things down. If your cache hit rate is low, every request pays the network penalty to check the cache before hitting the database anyway. Monitoring and calculating cache hit ratios is essential to ensure your caching strategy is actually improving performance. Caches eventually run out of memory and need to evict data. The right eviction policy depends on your use case. Least recently used, LRU, is great for content feeds, but not for session stores where you risk logging out active users. Choosing the right policy ensures your cache behaves as expected under pressure. APIs are contracts with your clients. Changing a live API's payload can break existing mobile clients that haven't updated in years. To avoid this, you need to understand API versioning, either through headers or URLs, and how to maintain backward compatibility. This ensures your users aren't disrupted by necessary changes. Rate limiting protects your APIs from abuse. A fixed window counter allows clients to burst their limit at the boundary of 2 windows, while a sliding window smooths out the limit. Each approach has different memory and implementation trade-offs. Understanding these mechanics helps you choose the right strategy for your system. Designing an endpoint to upload a 5 GB video file requires special handling. You can't read the entire file into memory on your server. It would crash the process. Instead, you should use streaming uploads, multi-part chunking, or presigned URLs that let clients upload directly to cloud storage. These techniques ensure reliability and scalability for large file uploads. Some API requests trigger long-running tasks, like generating a PDF. If the process takes too long, the client connection may time out. The solution is the asynchronous worker pattern. The API returns a 202 accepted with a job ID, and the client pulls a separate endpoint to check the status. This keeps your APIs responsive and reliable. Message brokers are essential for decoupling work in backend systems, and Kafka serve different purposes. Kafka is a distributed log designed for high throughput and replayability, while RabbitMQ excels at complex routing and task queues. Knowing which broker fits your use case is a valuable skill for backend engineers. If your Kafka consumer reads a message but fails to commit the offset, it will read the same message again when it restarts. This means your processing logic must be idempotent, so that processing the same message twice doesn't cause errors or duplicate results. This is a core concept for reliable message processing. Sometimes, a malformed message causes your worker to crash repeatedly. These are called poison messages. To handle them, you use dead letter queues and set retry limits. This prevents your system from getting stuck on a single bad message and allows you to investigate and fix issues without impacting the rest of the queue. In distributed queues with multiple consumers, guaranteeing message order is challenging. Consumer A might process message 1 slower than consumer B processes message 2. To maintain order, you use partitioning or routing keys so that related messages go to the same consumer thread. This approach is essential for systems where order matters. Looking at all these questions together, it might seem overwhelming if you try to memorize everything at once. But if you take the time to understand the problems these concepts solve, you'll find them manageable. Each question is about dealing with scale, failure, and real-world issues that backend systems face daily. Every one of these questions is rooted in the realities of backend engineering. Databases slow down, networks drop connections, and users send unexpected data. Senior engineers spend their days mitigating these exact problems. By understanding the pain points behind these questions, you'll be better prepared to tackle real-world challenges. If you're looking for a structured way to study these concepts, consider using resources that organize backend technical rounds by topic. These resources often provide specific follow-up questions that interviewers use to test your depth of understanding. Focus on grasping the underlying issues, not just memorizing answers. The key takeaway is not to memorize answers, but to understand the pain points these questions address. When you truly grasp the underlying problems, the solutions will make sense, and you'll be able to discuss them confidently in interviews. This approach will help you stand out from candidates who rely solely on rote learning. Let's quickly recap the database-related questions: indexing random UUIDs, efficient pagination, composite indexes, and the N+1 query problem. Each of these topics addresses a common performance or scalability issue. Mastering them will help you design and maintain robust backend systems. Concurrency and transaction management are at the heart of distributed systems. Preventing double booking, understanding isolation levels, and implementing distributed locks are all about ensuring data consistency and reliability. These are foundational skills for any backend engineer. Caching can make or break your system's performance. Understanding cache stampedes, invalidation strategies when caching can slow you down, and choosing the right eviction policy are all critical to building scalable and reliable systems. APIs are the backbone of modern applications. Safely changing payloads, implementing rate limiting, handling large file uploads, and managing long-running tasks are all about providing a reliable and user-friendly experience. These skills are essential for any backend developer. Message brokers like in Kafka are vital for asynchronous processing. Choosing the right tool, handling offsets and idempotency, dealing with poison messages, and ensuring message order are all about building resilient and scalable systems. A common mistake is focusing too much on memorizing architectures and not enough on understanding how systems behave under stress. Interviewers want to see that you can reason through problems and explain trade-offs, not just recite textbook answers. Practice discussing these concepts out loud to build confidence. Seek out actual interview questions from companies you're interested in. Practicing with real questions helps you identify gaps in your understanding and prepares you for the types of follow-up questions interviewers might ask. Focus on explaining your reasoning and the trade-offs involved in your solutions. Don't be discouraged by failed interviews. Each one is an opportunity to learn and improve. Many successful engineers have failed interviews before landing their dream roles. Use each experience to refine your understanding and approach. The best way to master these concepts is through hands-on experience. Work on projects that challenge you to solve real backend problems. Experiment with different database indexes, caching strategies, and message brokers. The more you practice, the more confident you'll become. Backend technologies evolve quickly. Stay updated by reading blogs, attending meetups, and participating in online communities. Continuous learning ensures you're prepared for new challenges and interview trends. Connect with other backend engineers to share experiences and insights. Peer discussions can help you see problems from different perspectives and deepen your understanding. Networking also opens doors to new opportunities and resources. Participate in mock interviews to simulate the real experience. Mock interviews help you practice articulating your thoughts, managing time, and handling unexpected questions. They're a safe space to make mistakes and learn from them. Seek feedback from peers, mentors, or interviewers after each practice session or real interview. Constructive feedback helps you identify areas for improvement and refine your approach. Iterative learning is key to long-term success. Confidence in interviews comes from genuine understanding, not memorization. When you can explain concepts clearly and discuss trade-offs, you demonstrate the depth of your knowledge. This is what interviewers are truly looking for. Backend engineering is a journey of continuous improvement. Each project, interview, and learning opportunity builds your expertise. Stay curious, keep experimenting, and never stop refining your skills. There are many resources available to deepen your backend knowledge. Books, online courses, blogs, and open-source projects can all help you explore topics in greater detail. Choose resources that encourage hands-on practice and real-world application. Interview preparation can be challenging, but staying motivated is key. Set small, achievable goals, celebrate your progress, and remember why you started. Every step forward brings you closer to your goal. Mastering backend interview questions is about understanding the real-world problems they address. Focus on the pain points, practice explaining your reasoning, and keep building your experience. With time and effort, you'll be ready to tackle any backend interview with confidence. As you prepare for your next backend interview, remember that understanding beats memorization every time. Stay curious, keep learning, and approach each challenge as an opportunity to grow. Good luck, you've got this.